What if an electronic device could learn from data instead of being programmed for every possible situation? That's the basic idea behind machine learning. Machine learning is a way of teaching computers to recognize patterns in data and use those patterns to make predictions or decisions. In traditional electronics, engineers usually tell a device exactly what to do using programmed rules. If something happens, the program follows a specific instruction. But what happens when the situation becomes too complicated to describe with simple rules? That's where machine learning can become useful. Instead of programming every rule manually, machine learning can learn patterns by studying examples. For electronics, that data can come from sensors measuring temperature, light, sound, motion, current, voltage, vibration, and many other physical signals. The machine learning model looks for patterns in the data. Similar patterns can be grouped together, while unusual patterns can stand out. This means sensors can become more intelligent. Instead of simply measuring a value, a system can learn what those measurements mean. For example, a vibration sensor could learn what normal machine behavior looks like, and then identify a pattern that seems unusual. Machine learning gives electronic systems a new ability. They can learn from data, recognize patterns, make predictions, and sometimes make decisions. The first step is collecting useful data. In electronics, this often means recording measurements from real sensors and circuits. Next, the data is used to train a machine learning model. The model adjusts itself as it learns the patterns contained in the examples. During training, the model can be shown examples of different conditions, such as normal operation and faulty operation. After training, the model should be tested with data it has not seen before. This helps engineers check whether it has actually learned useful patterns. Once the model works, an optimized version can sometimes be deployed onto electronic hardware, such as a microcontroller or embedded computer. However, electronic devices often have limited memory and processing power, so the model may need to be optimized to run efficiently. Once deployed, the system can analyze new sensor readings and make predictions in real time. One common machine learning task is classification. The system receives data and decides which category it most closely matches. Another useful application is anomaly detection. The system can learn what normal behavior looks like and flag something that seems different. When machine learning is combined with electronics, a device can sense the physical world, process the data, recognize patterns, and respond automatically. Machine learning can make wearable electronics smarter by learning patterns from movement and other sensor data. In smart homes, machine learning can help devices recognize activity, detect unusual behavior, and respond more intelligently to their environment. In industrial electronics, machine learning can help detect unusual vibration, temperature, sound, or electrical behavior before equipment fails. In agriculture, machine learning can analyze soil and environmental data to help smart systems understand when plants may need water or when conditions are changing. Robots can use machine learning to recognize objects, understand movement, detect sounds, and interact more intelligently with their surroundings. In autonomous machines, machine learning can help systems interpret sensor information and make decisions about what to do next. But machine learning in electronics has challenges. Limited memory, processing power, battery life, and poor quality data can all affect how well a system performs. As electronics become more powerful and machine learning models become more efficient, intelligent features could become part of more devices around us. The big idea is simple. Machine learning allows electronic systems to learn patterns from data and use what they learn to make predictions or decisions. Machine learning may sound complicated, but the basic idea is simple. Collect data, learn patterns, make predictions, and take action. As electronic, thanks for learning with Ethan. If you enjoyed this lesson, don't forget to like, subscribe, and turn on notifications so you never miss another easy-to-understand engineering video.